this assignment builds on what you did last week. So last week you looked at equations and you looked at tables, and some of you made graphs to look at the tables and the equations to decide if the function was linear or not linear. A piece we're adding this week is moving from a description in words of what's going on, and then to decide if these words describe a situation that is a linear function or not. And we have the instructions make it sound like there are just two options, because it says determine whether each representation models a linear or nonlinear function. So it makes it sound like you're deciding, is it linear or not linear? But in reality, there's this other word here. You're also deciding, is it a function? So here are the choices you're going to have when you're answering on this assignment. You're going to be deciding if the representation is of a linear function. You're also sometimes going to decide that the representation is not linear. Maybe it's a curve or something like that. And there's another option that maybe it is linear, but it's not a function. So these are going to be your choices: linear function, not linear, or yes, linear, but not a function. So here's an example of something that you would decide is not a function. There's a graph, there's your coordinate plane, and there is a graph on here of this oval shape. So the way you know that this graph is not showing a function is that it fails the vertical line test. So with the vertical line test, what you do is you take a vertical line that's straight up and down, right? And then you see if that line can ever touch the graph more than once at the same time. So here it's not touching it all. That's okay. This is okay. Here it's touching once. That's also okay. Still a function. It could still be a function. But the minute you see this, that the graph is touching the vertical line more than once, you know this is not a function. So not a function, not a function, not a function, not a function, because the graph is touching the vertical line more than once. So for something to be a function, the x value down here has to have only one y value. Here, this x value right here has a y here, and there's another y value right here. So the same x here has two different y values, and that's not allowed for functions. So this is not a function. So when you're looking at graphs, or when you're looking at tables, think about, on the table or on the graph, does the same x value have more than one y? If the same x is paired with more than one different y value, it is not a function. Now, when you get up to this top part, when you're looking at the words, at the descriptions of what's going on in words, you may want to make yourself a table if you're not sure at first. So let's take this first scenario. So what happens is you have a tree, and each year the tree grows another 3.5 inches. So these are the years, and this is the inches that the tree grew. Okay? So this is kind of like the x, right? The input value and the output value. So each year, the tree grows 3.5 inches more. So after year 1, the tree grew 3.5 inches. Then, after 2 years, each year the tree grows 3.5 inches. So the tree grew 3.5 plus 3.5, so 7. Right? How tall is the tree? How much taller is the tree going to get after 3 years? So you decide, if you filled in this table with this pattern, is this linear or not? Then do the same thing with the next scenario. So scenario B. In scenario B, you have hours. So this column is going to be the number of hours since the patient took medicine, right? So at time 0, the medicine is at full strength. So times 0, there's 100% of the medicine is in the patient's system. Times 0, right? That's when you first took it. It's full strength. Now, after 1 hour, it decreases by 50%. So it's cut in half. So after 1 hour, you're at 50% strength. So what's going to happen after 2 hours, after 3 hours? You fill out the pattern and decide, is it linear, is it nonlinear, or is it not a function at all? The next one is you're looking at the area of a square depending on the lengths of its sides. So what you're looking at here, if you remember, you'll have to review a little bit about what you know about squares and area. So if you have a square, I'll do my best to draw a square, not a rectangle. I mean, it's a rectangle, but it's also a square. So all of these sides are the same length because this is a square. And what the area of a square is it's the length times the width. So if this is the length and this is the width, right? All rectangles are like that, length times width. But since this is a square, we don't have two different numbers. We have numbers that are the same. So say that the width is 2 inches. Let's just say 2 inches. It's also going to be 2 inches over here. Area is this side times this side. So if you take 2 times 2, that's going to give you 4. If the sides of the square were 1, 1 times 1 is 1. If the sides of the square were 3, 3 times 3 is 9. Okay? So you fill in this is the side length, and this is the area. So this is the side length, and this is the area. You fill in your table, and you decide, is this linear or not linear?